Today I'm going to share with you how exactly did I do it, because there is something definitely worth sharing about in this video. So for the only one who are efficient, effective and smarter in listening and learning. And let's begin without any further delay. So today's topic is mathematical induction. So this is very helpful for all the discrete mathematics. So this is related to MFCS, DMS and DMGT. So today, using mathematical induction, now we are going to prove the following, that is 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus and so on up to n terms, which is equal to n into n plus 1 into n plus 2 into n plus 3 by 4 for every n belongs to a natural number. See, the solution here will be, first of all, we have to find the nth term. See, here we have to find up to n terms. So we have to find the nth term. So in order to find the nth term, what we have to do? First of all, we have to find the nth term. So here is the question. First, we have to select 1, 2, 3, the first terms. So here 1, 2, 3, which are in AP. So clearly the difference between each and every number is 1. Therefore, they are in AP. So we have a formula that Tn is equal to A plus n minus 1 into D. So in this, if I keep, so A value is the first value. So A value is 1. N minus 1 into D is the difference, that is A2 minus A1, that is 2 minus 1, which is equal to 1. So if I substitute A as 1 and D as 1, and see, this will be 1 plus n minus 1 into 1. So if I cancel this plus 1 and minus 1, so it will be n. So the next thing what we have to do is, so we have to select the second terms. So where these are the second terms, that is, here is 2. So this is 2, this is 3 and this is 4 and so on. Next we have to select 2, 3, 4, which are again in AP, because the common difference between any two number is same, 1. So here again we have to go with the formula, that is Tn is equal to A plus n minus 1 into D. So here what is our A? A value is our first value 2. So we have to substitute in place of A as 2, and here the difference A2 minus A1, that is 3 minus 2. The difference here is D, and A value is equal to 2. If I substitute in this formula, then this will be A plus n minus 1 into 1, that is 2 plus n minus 1. So this will be n plus 1. And the next thing what you have to do is, so you have to go with the third terms. So here the third terms are 3, 4, see here, this is 3, this is 4, this is 5 and so on. So for the third term, so this is 3, 4 and 5, which are again in the AP. So again the same formula which we have to use, that is Tn is equal to A plus n minus 1 into D. Here our Tn value will be, the first value here A is equal to 3. So now I am going to substitute A value as 3 and D difference 4 minus 3, the difference between A2 minus A1 value will be the D difference, common difference D, that is 1. So after substituting A as 3 and D as 1, and see solving here, that is 3 plus n minus 1. So this will be n plus 2. So these are all multiplied. The first term, second term, third term are multiplied here. And therefore, if you observe, the nth term will be, so the nth term will be here up to nth terms. So here we found the nth term as a multiplication of n into n plus 1 into n plus 2. So 1 into 2 into 3 plus 2 into 3 into 4 plus and so on, n into n plus 1 into n plus 2 value will be n into n plus 1 into n plus 2 into n plus 3 by 4. So this is the actual question. So this is the actual question, because here the nth term is not given. And therefore now we have to go with the substitution method. In the mathematical induction, first we have to select which one we have to select. Put n is equal to 1, we have to choose, and next one n is equal to k we have to assume, and later we have to substitute n is equal to k plus 1 on the both sides. If they are equal, then we conclude that the given statement is true for all positive integers. So first I am taking the statement. See here, the statement here is nothing but, that is 1 into 2 into 3 plus 2 into 3 into 4 plus and so on. The nth term which we found now, that is n into n plus 1 into n plus 2 is equal to n into n plus 1 into n plus 2 into n plus 3 by 4. So let Sn be the statement. So this is the statement. The first step what we have to do is, so we have to put n is equal to we have to put n is equal to 1. So in this, if I keep n is equal to 1, so we have to check LHS and RHS. So here the left hand side here is any term 1 into 2 into 3. So here if I take 1 into 2 into 3, this value is 6. So this is our LHS value. So this is our LHS value. So in this, if I keep, this is RHS, sorry, this is RHS value. In this, if I keep n is equal to 1 here, this will be 1 into, this is 1 plus 1, this is 1 plus 2, 1 plus 3. So clearly this is 2 into 3 into 4 by 4. So if I cancel 4, so this is again 2 into 3, which is equal to 6. So LHS value we got 6. And next one, RHS value also we got 6. Therefore, we say that LHS is equal to RHS for the value n is equal to 1. And therefore, for the statement S of 1 is equal to true. The first thing is happened. The next thing is we have to assume S of k is equal to 0. So we have to assume that in the given statement. So this is the statement. In this, we have to assume n is equal to k is true. So straight away we have to take in place of n as k, that is 1 into 2 into 3 plus 2 into 3 into 4 plus this value is k into k plus 1 into k plus 2, which is equal to. So here in place of n I am taking k here, that it will be k plus 1, k plus 2, k plus 3 by 4 divided by 4. And the next thing here is we have to take n is equal to k plus 1. So this is for n is equal to k plus 1. So this will be equation 1. So this will be equation 1 if I take n is equal to k in the given statement. And next one, the next thing what we have to do is we have to put n is equal to k plus 1. So for putting k plus 1, so we have to take the nth term here. So what is our nth term here? Generally this is our nth term which we found. So this is our nth term. So in this nth term, n into n plus 1 into n plus 2, keep n is equal to k plus 1. So this will be k plus 1. This is k plus 1. So this is k plus 1 plus 1. And this is in place of n. If I keep k plus 1, this will be k plus 1 plus 2. So which is equal to k plus 1 plus k plus 2 plus k plus 3. Now what we have to do is, so we have to adding this k plus 1th term on both sides of equation 1. So what is our equation 1? So S of k is our equation 1. So both sides we have to add this k plus 1th term so that it will be very easy for us. So now see what I'm going to do. So this is our equation 1. Now I am adding k plus 1 into k plus 2 into k plus 3 on both sides. See this one. What I'm going to do is, see, read properly this one. This is our first equation, which is S of k, that is 1 into 2 into 3 plus this is 2 into 3 into 4 plus and so on. This value is k into, this value is k plus 1 into k plus 2 plus. See here, now I am adding this k plus 1th term, that is k plus 1 into, this is k plus 2 into, this is k plus 3 on both sides. So here on both sides, on this side also we have to add, that is k into, this is k plus 1 into, this is k plus 2 into, this is k plus 3 by 4 plus both sides I am adding this one, that is k plus 1 into, this is k plus 2 into, this is k plus 3, this is k plus 3. So here now I have added this term. So which term I have added? So this k plus 1, k plus 2, k plus 3. And this is k plus 1, k plus 2, k plus 3 on both sides of equation. So this is equation 1. So in equation 1 I have added. So this is equation, S of k is the equation. So this side and this side I have added this term. And now I'll check whether what happens here. So this is LCM 1. So if I take 4 and 1 as LCM, 4 will be the LCM. So now see what happens here. So 4 will be the LCM. So this is k plus, so this is k plus 1 plus, so this is k plus 2 and this is k plus 3. So 4 times, this is 4 times of, this will be k plus 1 into, this is k plus 2 into, this value is k plus 3. Now which terms I have to take common? See, I am taking common. So here k plus 1 is a common term for both, and k plus 2 also a common term, and k plus 3 also a common term. And now if I take all the common terms here, then what happens here? So if I take k plus 1 is a common, k plus 2 common, and k plus 3 common, then what remains here? K by 4. Here it is k by 4 if I take these 3 as common terms. So this will be 4 and this is whole by 4. Clear? And see, this can be written as k plus 1 into, this is k plus 2 into, this is k plus 3 into, this value is k plus 4 by 4. And clearly this can be written as k plus 1 into, this is k plus 2 into, this is k plus 3 into, this is k plus 4 whole by 4. So this is nothing but, so here if you see, so this is our RHS part. In RHS part, if I keep n is equal to k plus 1, so this will be k plus 1. So if I keep n is equal to k plus 1, this will be k plus 1 plus 1. So this will be k plus 2. If I keep n is equal to k plus 1, this will be k plus 1 plus 2, this is 3. And this value is k plus 1 plus 3, this is 4. So this value will be k plus 1 into k plus 2 into k plus 3 into k plus 4 by 4. So exactly we got the same thing, that is k plus 1, k plus 2, k plus 3 into k plus 4 by 4. So which is nothing but s of k plus 1. And therefore finally we got s of k plus 1 is true. Therefore s of k plus 1 is true. It is a true value. Therefore the given statement, the given statement is true. Is true for every n belongs to capital N. Therefore, our statement is true for each and every number. So back to the beginning once again. So this is the question given. So in this question, if you see, so first of all, we have to select 1, 2, 3 and so on for finding the nth term. So this is in the AP and therefore this is the formula. Here we have to take A value as 1 and the D common difference as 1, and therefore we got Tn value as n. And here after selecting the second terms, that is 2, 3, 4 and so on, these are also in AP, and therefore after substituting in the same formula here A value will be 2 and D, the common difference will be again 1 here, and after substituting this will be the nth term. And here after selecting the third terms, that is 3, 4, 5 and so on. So here the same formula here, A value will be the first value 3 and D will be the common difference, that is 3 plus n minus 1, that is n plus 2. So here this is the nth term and this is our RHS value. So this is the statement given. So in this statement, so we have to select this as a statement and this in this statement. So first of all, we have to keep n value is equal to 1. So after keeping n value is equal to 1, so the LHS part is 1 into 2 into 3, which is equal to 6. In the RHS, if you keep n is equal to 1, so here this is 1, 1 plus 2, 1 plus 3, 1 plus 3 by 4. So here this is also 6. So we got the same values, 6 and 6. LHS is equal to RHS for n is equal to 1. Therefore, S of 1 is equal to true. And the next step is we have to assume that S of k is true. So we have to take the statement and we have to keep n value as equal to k in LHS and RHS. And we have to assume that statement as equation 1. And the next thing is we have to keep n is equal to k plus 1. So for that, so here is an nth term. So we have to add k plus 1th term on both sides of the given equation. So here our k plus 1th term will be, this is k plus 1, this is k plus 1 plus 1, this is k plus 1 plus 2. So this will be k plus 1, k plus 2, k plus 3. So I am adding this term for equation 1. So after adding the equation 1, so on the both sides after adding, so here I have taken this RHS part and after calculating this one. So what are the common terms here? K plus 1, k plus 2 and k plus 3 are the common terms. Here what is left over? K is left over and here 4 is left over and divided by 4. This will be k plus 4 by 4. So which is equal to this one. So if you observe properly, this is the n plus 1th term from RHS. See here, if you keep n is equal to k plus 1, see this will be the answer, that is k plus 1 into k plus 2 into k plus 3 into k plus 4 by 4. So we got exactly the same answer. So it is true for n is equal to k plus 1. So if it is true for n is equal to 1, 2, 3, k and k plus 1, and obviously we say that the given statement is true for all positive integers. Thank you so much for watching, and this is for today, and I'm going to post so many videos related to the mathematical induction. Please avail the opportunity of preparation, and please pass it on if you really like, and raise your thumb, subscribe to this channel and stay connected, and look at my next video too for your support. Thank you so much. Thank you so much for watching.